Welcome to live stream number 114. My name is Lars Christensen, and today, it's Friday, man. We made it. Today's topic is cam. Today is when cam flashes red. And this one today is inspired by one of you guys who reached out about cam when you're simulating, how you sometimes get a lot of red lines down in the simulation area. What is that, and how do you get rid of it? So that's what we're going to talk about today. All right, I can see we already got Tommy in here. Absolutely appreciate you here. Well, got a couple of other people. Let's just get into it. So, Fridays is cam. So if you're not into cam, take the Friday off. Get a beer, a cup of coffee, whatever. Kick back, relax, man. You probably worked hard this week. For the rest of us, let's do some cam. So today we're going to use this model here. Now, some of you guys maybe have seen this one before. This was kind of like a core I built for a reciprocating saw thing we did a long time ago here at Autodesk. But I thought that would be an interesting model to use when we are talking about collisions and all this awesome stuff that happens when we are camming. So let's jump over in the cam workspace, and we're gonna do a setup. Now I'm just gonna throw a setup on here. I always use select Z-axis, and we have done other live streams on how to set all this up. So I'm not going to bother with this, but pretty much we're putting the origin in the center of this part. I'm not even going to change the stock. I'm just going to leave it at the default relative size. Doesn't really matter. Let's hit OK. Okay, so we're ready to apply our first toolpath to this part. And even if you are, I'm going to use some 3D toolpath on this one just because that's kind of like where this part leans towards. Even if you're brand new, don't worry too much about all the specific picks and clicks here. I think it's more about getting the overall value of this. Now, I'm going to rough this out with 3D adaptive clearing. So I'm going to select that, and we're going to go in and select a tool. That's always the first thing we do, right? And normally, when I do these live streams, I like to just select out of the metric tool catalog here. We have a 16 millimeters, but actually look how long the shaft is. I don't know if you would ever use such a long one on this part. So what I'm going to do is I have created one, just a standard. It's a 1/2 inch or 12 millimeter. That's more, I think, more realistic. 12 millimeter with about, 25 millimeter flute length on it. Hit OK. And that's a good stoppy end mill to kind of like rough things out. Now, as I've said before, whenever we are doing any 3D toolpath, what I like to do is just select the tool and then hit OK and see what you get. Okay, and I'm saying this because whenever we are working with 2D toolpath, we got to go in and select geometry first. But with 3D toolpath, the software will actually find what it can machine depending on the model we have. And I gotta admit that when I started out, I used to be a little bit frightened when I got into 3D toolpath because it used to be so complex. But Fusion is really good at this. So I normally just select my tool and hit OK and kind of like see what the software gives me. And we can see here that Fusion is calculating the toolpath as I'm talking here. You get kind of like a little percentage. By the way, Fusion is actually using multi-core processor or something when it's doing toolpath calculation. You can actually start applying new toolpath while one is already calculating. So don't think that you always have to sit here and wait for the first toolpath to calculate. If I knew I was going to drill some holes, I could absolutely right now go up and start picking geometry for drilling while that is calculating right there. Now, but this goes fairly quick here, as you can see. Just about actually done here. Now, what adaptive does is it calculates the specified stock versus the CAD model on our screen. So that's how it does this selection. Now, if you're new, this here, what we're looking at here, might look a little overwhelming for you. Looks like there's a lot going on. But like I said, select your tool, hit OK, see what you get, and then start to kind of like work your way backwards from that. So one thing I noticed is that this toolpath, as it should, machines all the way down to the bottom of this part. But I actually originally had this part with some clamps holding on here and stuff like that. I really only wanted to machine to this surface right here. So I'm going to go in and change that. So I'm going to right click on adaptive, go in and hit edit. And anything with the height tab is the third tab over here. Now we've covered this one in another live stream. So if the height tab had been confusing to you, send me an email. It should be down in the description area of the video, lars.christensen@autodesk.com. And I'll make sure that you find it if you can't find that live stream by yourself. But as I said in the live stream about the heights tab, just always start from the bottom and work your way up. So bottom depth is right now set to the bottom. This says model bottom, so that makes sense. I'm going to change it to selection, and then I'm just going to select, because selection, that top face, and now the heights will only go to there. So I'm just kind of like eliminating things as I am kind of like working my way through that. So again, we have people coming in here. Whenever I'm doing a 3D toolpath, I select the tool, I hit OK, see what I get, and then I go back in and I kind of like, eliminate one thing at the time as I'm going through. Instead of going in and trying to change a million things, hit OK, and then you don't really know what changed what. It's better off going the other way around. So now at least it's not machining any further than there. Now let me just show what I'm talking about when cam is flashing red in Fusion. Let's go up and hit the simulation tool. And we can turn on the stock in here and stuff like that. But you will see, if you look down the bottom down here, that we already are starting to get these red traffic lights down here that is literally like showing up like, I don't know. Okay, I don't have any. Like ants on a hot summer day. Look at all these red marks down here. Whew, it's Friday, man. I'm sorry. And that is what the question was. What the heck is all this? Well, it is collisions down here. And if I hover over them, you will actually see that Fusion tells me that it's holder collision. Now, what does all this mean? Well, let's turn the stock on. And I like to change the material to ceramic. So it's like that. And I almost do tail too. Okay, let's hit play. So we will see our cutter, our little stoppy cutter, starts to do an excellent job roughing a material away right now. Now we can talk about depth of cuts. It is actually a very shallow cut here. We can definitely go deeper with it. But what happens is that when we get closer to our actual shape, let me speed it up. See how that holder just turned red? Look at it one more time. When it hits that line down here right now, it's gonna go. That was the last one. All right, I'll fast forward a little bit. Next one down here. Look down here how I can just click down here. I can fast forward. Now it's gonna turn red. Red, right? So what happens is that we are standing on a machine. The machine is running, and the worst sound in the world ever. A tool holder that hits where it shouldn't be hitting. You can actually see that the graphic shows like it's coming off. Terrible sound. It's probably the day the boss is around and he wants to know what the heck is happening. This is horrible. So awesome that Fusion has this capability that it gives you a warning that there's some kind of a collision. This could either be tool holder, it could be that you're running out of flute length, or something like that. And yes, you should absolutely pay attention whenever you see that. Matter of the fact, when I used to program at Ridlam, I didn't care really what you had to machine. Nothing was allowed to be sent through the post-processing in CAM without having been sent through simulation first. Even when you think, oh, I know what I'm doing and I've done this before, and that's when mistakes happens. So you should always make it a habit to get in here in the simulation workspace before you post out any code to verify that you do not have any of these crazy collisions here where the tool is hitting the part. So we got to talk a little bit about, so that's, in this case, I'm going to show you a couple of different ways how this can happen and then show you how to kind of like resolve it. So I really like using a stoppy cutter for this, right? Because using that long end mill, let's just switch to that one. The first one in the tutorial library here, this one, I mean, that's a long cutter. Now, that might be good to clean up some stuff, but to rough all this material out, that thing will be rattling and chattering, and yeah, that, you know, that wouldn't be a great solution. And actually, with this one here that is right out of the catalog, you will actually see, just let it generate here, you will actually see that it will also touch. Give me 1 second, there we go. If we go in and we hit the simulate here, and we start playing through here, it looks very, like, a lot of distance, right? A lot of chatter, but you will actually see down in the end of the cut down here, it actually will also hit when it comes to the end of this, almost roughed it all down. It will actually touch right over there. See how it turned red. So so this tool here is not even good for that. So let's get back to our stoppy tool, because I want to show you a way around it. So I'm taking the stoppy one. We've already confirmed that it hits. Now, Fusion in the 3D toolpath has a really neat function down here called shaft and holder down here, and it gives you 3 different options. One is detect tool length. I'm going to show you that one just in a second. It will actually figure out how long the tool needs to stick out of the holder without colliding. So that's kind of awesome. There's also one fail on collision. I really don't use that one. It just will not, if it collides, it will just say, I can't process. I really like pull away. So what Fusion does is it will calculate, let's say pull away, and you can put in here like a shaft clearance and a holder clearance. It will calculate the holder to the stock. Now I said before that the depth, we could adjust the depth. Now this depth here, this flute length on this choppy one is 25, but I probably wouldn't go full depth of cuts. I'm just going to go 20 millimeters, so we're not going, you know, all the way down on each cut. And let's just hit OK here, and it's going to start calculating. Now, because I'm using the pull away, this is going to take a little bit longer to calculate, just because, you know, now we're actually having the software doing some pretty crazy calculations. But what is cool about this is that now it will actually create a tool path where the holder will step away from the finished area, so it's not going to collide. And it's probably easiest to see if I kind of like go to the front here. You can kind of see here on the blue how it starts to kind of like make a move out away where that tool holder kind of was right there, right? Easiest thing is maybe if we're going back into the simulation and go to simulation, and if we just click here, we can go to Endo Toolpath. Just give Fusion a second just to catch up here with the graphics. Ooh, it's thinking. Hang on. That does look rough, doesn't it? You can kind of see that it creates kind of that step over there. I don't know why that doesn't show that sharp. From the side here, maybe we can see it better here. So you can see how it's staying away from the finished shape right there. Maybe I will change the quality. But so it stays away from the finished shape. And that's exactly, what I want. That's coming along. Now, so that's great. Now we don't have any collisions down here. So that, achieved. Now I wanted to show you, so you say, all right, that's all good, Lars. But there's still a couple of issues. By the way, if any of you guys are looking at this right now and say, wow, that's a lot of rapids. I'm running Fusion in the default mode. And I talked about this in the live stream about adaptive. If you go in here and you edit, you go to the linking tab, I would normally go minimum retraction and stay down level to 50. And a lot of those rapid moves will go away. Actually, if you want this model, I'll share it with you too. I'm not going to do this right now because that takes like 4 or 5 minutes to calculate to do that. But that's how you'll get away with a lot of those rapids, just if you were thinking about that. Now, so we have something good right now. We kind of like roughed all this out. We don't have any collisions. But now we have a lot of extra materials on here. And I kind of like want to get rid of that. So that's maybe where we can start using the 2D or the long cutter we had before. Now I could go up here and create another 2D adaptive clearing, but remember we've already made different selections inside of this one. We can actually copy that one. If you right click, create derived 3D milling and adaptive clearing, we kind of like just took a copy of that first one and brought that in here. And then I'm going to select the long cutter, because I want this one to kind of like clean up after that stoppy cutter we just did. So I'm going to select the long one. Now we know that it actually did hit on this one. So instead of using pulling away, I'm going to use detect tool length. So now I'm letting Fusion pull this one out, how long it needs to come out. And then if I just hit OK right now, it's going to run all the same toolpath really as the stoppy one did and cut a lot of air. So I'm going to go to the Geometry tab in the rest machining. We're going to do another live stream on this. Don't worry, coming. In rest machining, we're going to change from previous operation, what means that Fusion now will look at the previous operation and only machine what needs to be machined. So you will see that this second tool path will kind of like clean up most of the areas, or the areas where we kind of like left material, or we kind of like be in this area right here. Well, we'll go in and kind of clean that up. And just because of the nature of it, you will see that we actually get some extra cuts right here. And that's because that we're having the same stock to leave on this one as we did with the previous one. I actually normally bump it up just a little bit, and you will get rid of those. Another thing that I just wanted to show you while we're in here, let it recalculate. You'll see a lot of these kind of like small steps gonna go away here because we bumped that away. Over here, we will get a yellow notification. Well, I regenerated, so now we don't get it. And now it shows up like, no, before I regenerated, I had a yellow rectangle over here. So what I did to get that yellow rectangle, I went here, right-clicked, show log, and you will see that it gives us a notification that it pulled this tool out of the holder. It was originally 70. It pulled it out 76.58 millimeters to make sure that it don't hit. So when we go in and simulate now, so here's the first adaptive. We go to finish that one up. Right, here is that. Then the last adaptive, it had pulled the tool out further, and now that one will go in and clean up those remaining areas in here. So I just want to kind of like show this on how to kind of like rough this in, so we don't have any more red marks down here. And this here would definitely be a good, I think, a good strategy to kind of like remove all this material. Okay, back to more cam red flashes in our area here. Let's talk a little bit about finishing toolpath. So, and this, I just want to show another example on where you many times get these red lines in your simulation. If I'm going to finish this area, and again, I did a whole other live stream about selection and parallel, contour, and all these different ones. I'm not going to touch too much on this. But I'm going to use a Scallop toolpath. And for that, I'm going to select the ball and mill. And I'm going to use the tutorial metric one. Ball and mill right here. Again, whenever I do 3D toolpath, I don't tweak anything. Just hit OK. And kind of see what you're getting. And then you can kind of like start eliminating from there. Now, again, I'm not going to make this toolpath 100% perfect. It's more about showing you how to eliminate things in the calculation. So, one thing I notice on this toolpath is that, again, that is touching my flat area, but I kind of like wanted to get down to that area. One way we could kind of like work with that would be to limit the area it can work within. So if we go to the geometry tab, right now it's silhouette. There's like a lamp shining down on it. We could go in and select selection and select this edge. So now we get a green boundary. Hit OK, and now the toolpath will only machine within that green boundary area. So that looks better. Now you will see, talking about issues, that because I have these venting holes in here, sitting here, the toolpath dive into that. Normally they would probably not be in the model when you were machining it. So they would probably normally be actually be patched at this point. But just to kind of like move on away from that, I'm going to right click, edit, and I'm going to go back into the geometry tab, and I'm going to use avoid surfaces, and I'm just going to select those inside surfaces. And that means it's not going to machine over them like they were never there, but it's going to avoid them. This is kind of like a Friday afternoon from Lars cheap fix, just to get to what I want to show you. And there. Now we're avoiding them. Now there's still a couple of some rapid moves. The way the software calculates this, we could go in and work with that, but let's just leave this right now and say that this is somewhat okay. Now, first, let me show you. If I go back into the simulation spot, this is probably one of the biggest mistakes I do. See here how we got red lines before. Now it's crazy. Just see how it's kind of like building out down here. Don't worry. I made a mistake. When I hit simulate, I only had the Scallop toolpath selected, what means that Fusion is looking at this whole big block, and like there's going to be numerous collisions. Whenever you gotta simulate something, click on the setup, then hit simulate. But now you're saying, well, Lars, we already confirmed the two first adaptive are good. I don't want to watch those again. Just now click on the operation you want to go to. You click on that, and it's going to rough to that area right there, and kind of like give you that. I'm just gonna see here if I can get that simulation a little bit better. That's a little bit better. Okay, so we can kind of like see what we're working on here. So now you will see that it's going to process it. Now you will see here though that down in the lower right, I do get some more collisions, and this is what I wanted to show you. If I hover over them, these are not holder collisions. These are rapid collisions with stock, and this is the most common ones I get. Now let's just start simulate this. You see that it kind of like is going to start machining it here. I'm going to turn the stock on for a second. If we get a little bit closer to it, see how the color is going to come down. It's going to lift up, and then it's going to turn red when it comes down. Right there, you saw that? Gonna do it again in just a second. There again. This is one of the most common things. I'm gonna show you another trick here, by the way. I'm gonna pause the simulation. It's running right now. I'm gonna pause the simulation. Now, if you never knew this, you're gonna love this. Hold down your left mouse button anywhere in the graphics area while you're in simulation, and look what happens. Hold down the left mouse button. If you start moving to side, the cutter will go backwards and forwards until the point wherever you want it. Ooh. So now, whenever we find there's a collision, I can position, hold down the left mouse button. Oh, there is a collision. Oh, it's gone. I can go backwards. There was the collision again. If you did not know this one, then you are going to be pleased. Okay. So what is this collision? Well, this collision is actually an entering material collision. And what normally causes this is that we have leftover stock from our adaptive, and now our finishing operation comes down, and the lead-in is not big enough compared to the material we had left from the previous operation. So the fix is pretty easy. We're going to go into the scallop, go over to the last tab, the linking tab. Down here, you have the lead-in, lead-out. Now, if I hover over the horizontal lead-in radius, you get a little picture that pops up. Mike Matara is the one who does a lot of these pop-up windows, and he does such a fabulous job. This one here shows the horizontal lead-in versus the vertical lead-in. So the vertical lead-in is kind of like the radius that comes down. Now, in this case, it's 1 millimeter. If we change that, just make it a little bit bigger, because that really doesn't really matter. You don't want it extremely big. But if we're changing this just to 5, what means we're going to make that radius, lead-in radius, a little bit bigger, and hit OK, then that arrow goes away. So if you ever kind of see that one, then you will kind of like see that will wrap it up. Okay, almost done here. We're getting up on the half-an-hour mark. I'm talking too much. Another thing, so you should be aware of, so everything I did so far was the 3D toolpath in here, and that's where you have the pull away or the shaft and holder collision. We do not have that for the 2D adaptive clearing, but it will still show you. So if I select that same half-inch end mill, and I say I'm going to rough out this area, I get actually, I love this toolpath here is just phenomenal. If I select the setup and then simulation, and then hurry up to that adaptive right there, you will see that everything is good. But if we turn the stock on here, we will actually get that collision showing up here with the holder collision on, or at least we should. Might be hard to see. So you can see it actually shows us here. So if we go back in and play through here, we should see it. Just let the poor computer, it's Friday, catch up. So here's everything is good. It's going to turn red that it's colliding. So you do get that notification, right? So now in our case, we're just going to have to say, oh, let me, I got to select a longer cutter. So I would select that long cutter we just had from before, the 16 millimeter long one, and then we would be better off, right? So you can do that. Another mistake that I sometimes do that causes collisions is when I'm drilling holes. So if I go in here and select drill hole, I'm just going to select the drill. I'm just going to pick one out of the tutorial library. And drill, 10 millimeter drill, that's fine. I'm gonna go in and select same diameter. If I select this hole here, it's gonna select all 4 in here. What is great, but what happens with these holes is, see how there's a little recess on top of it? Well, because I selected inside hole, because that's normally what you want to drill first, by default, if you go to the heights tab, the top height is the whole top. And in this case here, I actually need it to be this area. So that will many times, if I just don't change it and hit OK, that will many times cause collisions also when you get to the drilling cycle, because it's aware, it doesn't see that little recess. It says to start at the top of the hole, and in my case, I actually want it to be the top of the surface. So that's another kind of like oops I do sometimes, and again, why it's so stinking important that we do go out and we simulate here. The last thing I wanted to show you with this, so I gotta show you how you fix it. So go in, edit it, go to the heights tab, the bottom depth, actually in this case here, it's just drilling to the bottom of the hole. You would probably say put the drill tip through by, something. Then the fix is here. Instead of say hole top, I normally just say selection and then select that top face, right? So I can eliminate that. The last thing I want to show you is actually not this model. Let's go down here. This is a model we used a while back, and I should have had it opened. I thought I would have plenty of time. All right, this one here. One other thing about collisions that is important to know, and again, I'll share these models with you if you want to. Just send me an email. This one here, I've already got some Toolpath in here. Let's just get rid of those. Delete. If I go in here and I create a contour toolpath, I want to do something that is completely crazy. I'm going to select that same, whatever tool we have in here, doesn't really matter. 60 millimeter flat end mill, and I'm going to select that bottom edge here and hit OK. And if I go in and simulate this, you will see that I don't get any red marks. Though that if I did this out on the shop floor, that would be ugly right there, right? It's machining right through my jaws on my vise. Again, another, don't ever do that on a Friday, man. That will just completely ruin your weekend. Why is it not giving me any red marks? Here I actually want red marks. The reason is that this is an assembly right in here, and when I specified my setup, I selected just that plate as what I'm machining, but Fusion actually do have a fixture check mark. And if I select fixture in the setup and I select those 2 jaws, and I always, if you ever have something like you have fixturing in your models and stuff like that, again, best practice, make it a habit. You'll buy me a beer for this. Make it a habit to check on those fixtures as fixtures in here. Now, when I go in and simulate this, you will now see I do get 2 red marks down here, and it actually says that the tool collides with the fixture, and you will see that the tool is going to turn red on those 2 sides. All right, that, friends, was a Friday of Fusion 360 cam for you. I hope it was useful. When cam flashes red, there's definitely some ways to look at that. So I think the first thing you should look at was always, first of all, always simulate your toolpath. It is the way to look into the future, right? You're sitting there programming. When you run the simulation, it's like being in the future. That just makes it cool. Either you're colliding with your tool holder. That can be bad. Also, it could be the lead in, leads out that needs to be adjusted. And then the last trick here with the fixturing is definitely a must if you have kind of like an assembly in there. All right, guys, that was January 5th's 114th live stream. If you're watching the recording, really appreciate you take the time. Thumbs up if you like this. Thumbs down. I really appreciate when you take the time to do that. And if you haven't already, please subscribe to the channel. That's how I can go to my boss and say, hey, look, people are actually watching this. You guys are the best. Thank you so much. I'm going to end the recording. I'm going to jump into the live stream chat and say hi to everybody. And then we'll be back on Monday. Take care, guys.